would have been a safety. If he just kind of dropped it and it sat in there, and the other team recovered it, would have been a touchdown for the other team.
It would have been a touchdown for them?
If he would have, some people will drop the ball when they cross the goal line. If the other team would have recovered it, it would have been a touchdown.
Oh, that's
But some people will throw the ball. If it goes out of bounds, it would have been a safety.
I thought you meant if he just ran in the end zone and he didn't go down, then they would count the touchdown for the other team.
I don't get football.
I want to know what that guy said. Like, what was his excuse for running the wrong way?
Maybe
Maybe he is an offensive player, so he's used to catching it and then turning.
Maybe he was concussed and didn't know which way to switch.
Could be. It's always possible.
That's really hard to mess up.
Alright. I'm ready, Dr.
You ready? Any questions about anything before I do problems?
Nope.
Were we supposed to watch videos?
Yep.
It's just a monthly thing.
Fine.
So it's the exact same as the increasing and decreasing, but instead of I and D on the bottom, it's I to the M.
Oh, I watched chapter. Wait, were you still on chapter 8?
Yeah.
I watched chapter 9.
That's okay. I'm going to talk about chapter 9 today, too. So,
Okay.
even though I didn't say to watch the video, I'm going to talk about it some today.
I think we were.
So Grace is right. The idea behind the...
I already knew that.
What's that Grace is right?
No, she said, you're my favorite, and I said, I already knew that.
You gave me a fry.
Oh, I see what you're saying.
Don't tell the cat. He'll yell at me.
Why?
For sharing food.
What's his name? Cool.
That's not the one I wanted anyway. That's not the one I wanted. Where is this? Oh.
Curly fries.
Oh, let's do this one first before I do the other one. So this is a continuously compounded annuity.
Just count. I think there's more people not here than there are here.
No, there's 4 people not here, 5 people are here.
Yeah. It's close though.
It's close. So this one's about a continuously compounded, or excuse me, a continuous, well, it's also got continuously compounded interest, but it's a continuous annuity. So it talks about making continuous increasing payments at a certain rate per year. So this is not unlike the monthly one, but I think this one makes a little bit more sense perhaps. All the formulas all look the same, right? So in this case, notice that the rate per year is 50 for the first year, then goes up to 100 the next year, and so on. So the first payment, if you will, so the first yearly grouping, is the same as the amount of increase. So we don't have to worry about splitting it into 2 parts. Right? So for the continuously compounded, we want the present value. For continuously compounded, we put the bar over the IA. And for some reason, I assume it's for typesetting purposes, the book, and a couple of different books both do this, and I don't know why. They put a bar over the I and then a separate bar over the A that's lower, because the I is lowercase and the I is capital and the A is lowercase. I have no idea why. Why is that just a bar over the top? I have no idea.
Why not just A?
Got me. It's weird. I don't like it. Anyway, so this is for 10 years. And the interest rate here will be still the I's, or annual, or whatever our period effective rate is. So this period here has to match with the period that the interest rate's on. Whatever that happens to be. Okay. So this is then still our regular formula that we have. So it's still annuity due, 10, in this case, because that's the number of years. The interest rate is still I. NV to the N. This V is also based on I, but what goes in the denominator is your force of interest, your delta. So what changes is what's in the denominator. Does that make sense? We okay with that? All right. So for this problem, then, we need to do what? I I need to compute that present value of that annuity due. I don't have my calculator out. But I also need to do something else to start with. Oops, that was fun. Notice that I've got what essentially look like mismatched interest rates, right? Your top is going to all be in terms of the annual effective rate, because that is the unit of time over which the payments are being made, and then it increases for the next period, right? So your numerator is all in terms of the annual effective rate. Your denominator is force of interest. What are we given in this case? We're given the force of interest, right? Because it's the continuously compounded rate. So we're given the denominator, but I've got to figure out the numerator's interest rate. So that's one of, I'll say, the trickier parts. I think there's two quote-unquote trickier parts that you have to worry about in this particular problem, or these particular problems. One is that your numerator and your denominator have mismatched interest rates for how they're being computed. Your top is, again, over the period of time over which the payment is spread and then increases over the next period. So that's why that I is a yearly rate. It's increasing over the payments increase each year. Does that make sense? Okay. The denominator is a force of interest, which is not a huge surprise that needs to be in here since everything's being done continuously. So, hey Marshall. So we were given the force of interest. How do we find the annual effective rate then? Okay, E to the force of interest is 1 plus I, right? So our I will be E to the delta minus 1. We agree? So if I switch over real quick to the calculator, clear that, and let's go ahead and clear the time value of money. If I do 0.07 and then take it to the E power and subtract 1, there's our interest, the 0.0725. That's our I, right? Others get that number, I hope. I'm going to store that for later use because I'm going to need to use that interest rate for both the annuity due and for the V to the N calculation, right? So I stored that in there. All right, so I need the annuity due, so let's change this over to begin mode. Payment of 1. The interest rate, I have to make it a percentage, so I'm going to multiply it by 100. Was the 7.2508. There's 10 periods, and I want the present value. So in that one we get 7.4463.
What was the thing on that?
Just 1, yeah. So let me store that number too. Wherever, I'm just using the different numbers on here to store it. I stored it at number 8, but store it wherever you like. All right, now I need to do 10 times V to the 10th, right? So pull back out the interest rate, add 1 to it, flip it upside down to make it V. So I use the reciprocal button, raise it to the 10th power, and multiply it by 10. So I got 4.9659. So what others got, if you're actually working along?
4.9.
Okay. So I need to subtract that from the 7.4463. At least I thought I did. What happened? Why did I? All right, let me do that again. flip it. Oops, not flip it, add 1 and then flip it to the 10th times 10, make it negative, and add it to the 7.4463. I don't know what happened. I must have missed the minus button. 2.4804, and then divide that by the force of interest. We get 35, 43, 47. What do I need to multiply that by now? 50, because that's the amount of increase. That was our first payment and the amount of increase. So multiply that by 50, and we get 1771.74. Is that an answer? Hey, look at that. So 1771.74. So see if I can get this back up here again so we can actually see the calculator. So we had this part was, I hate that I can't see the calculator, 7.4463, and this was 4 point something. You may remember what the number was?
4.96.
What was it again?
0.96.
9659, and then over 0.07. And then we need to take this answer and multiply it by 50, right? So I should have a 50 out in front of each of this part. So we got 1771 and whatever the change was, 74. That one okay? Everybody happy with that? That one wasn't too bad? All right, so that's what you're increasing, or continuously increasing. Nope, that's not the word I want to use. This is continuous paying annuity that increases by a certain amount each year. In the next chapter, we will have another thing that's called an increasing continuously annuity, which is different than that. Because of course it is. What's that?
So that one has
That one has intervals in it, yes it does.
Did you say this was called, Dr. Good?
This is a continuous payment annuity that increases per year. It's different than a continuously increasing annuity. Because that would mean that the amount would go up continuously. The amount is continuously paid for the year, but it's level for that year. The amount's level for that year. Then it jumps, and then it jumps.
Right.
Okay. It's weird words. At least I think it's weird words. Okay. This one okay with everybody? Yeah. Go ahead.
How does this one differ from the previous ones going up continue?
The only difference is that
What does he mean by
in real life. So in real life, when financial transactions are made, the interest rates are computed at the instant. Whatever accumulated interest is done is calculated at the instant where the transaction is done. It's not, oh, I only compound this interest every year or every quarter or what have you. I'm going to compound that interest at every single moment that I can up until the transaction is made. It's basically best case scenario for computing interest, if you will, because we're doing that limiting idea. So in this case, somebody's supposed to make a payment at a rate of $50 per year to whatever business, but if you make a transaction to say this is a loan that somebody's paying back, and you're a bank, and you sell that loan to somebody else in August, say at the end of August, so that you had it for 8 months. So 2/3 of that 50 is yours, and then the other 1/3 of the 50 is the other. So that's where that means in the real world, if you will. They actually would take that $50 over the whole year and split it at the instant where the transaction's made to figure out who actually has that money. That's where it's used. These are very, very contrived examples, but that's how it works in the business world when they do those things. with the advent of being able to do this all with computers, that's when this stuff started taking off. Because in the past, when you didn't have computers, you had big tables that were calculated out ahead of time, so that when transactions were made, people would go to the tables to figure out what the values were at certain times. But now with computers, just let it do the work. Does that help answer your question? Okay. Say that again.
Why would we learn this if computers just do it?
It's fast the test. Well, the other part is that as far as the formulas go, my guess is if you do this as an actuary, you'll never actually use the formulas again because the computers will do it. But you do need to know where the things come from and understand what an annuity is. I think the understanding of the actual stuff is more important than actually doing these formulas. But, like Haley said, if something comes out screwy, you should have some sort of a sense of if it's screwy or not. Honestly, I think it's more important to know where things come from so you understand the concept. And the formulas are just a byproduct of that. However, it's that stuff that's what you're testing over on the actuarial exam. So, in the grand scheme of things, that's why you're learning it. But look how much of the calculator does for you.
Yeah.
So. What's that?
Since what I'm hearing is you're teaching to the test.
For this class? You're darn right I am. I am. I know what you're saying, but yeah, for this class, yes, I am. I agree. I don't typically do that.
It's a nice refresher, honestly.
What's that?
It's a nice refresher. They
What?
teach you to the desk.
Yeah, I don't. That's not what I typically do, which is why we do derivations of formulas and try to understand at least what's going on. All right, speaking of trying to understand at least what's going on, let's look at this problem. This is an increasing empthly example. I'm going to go through the problem in two different ways. And hopefully at least one of them will make sense. That's the hope. All right, so here's why this is an increasing empthly. We've got $10 payments. I assume they're dollars. Haley was mentioning this the other day. Apparently when you do these actuarial problems, they don't ever put the dollar on there. It's just pays 10. It pays 10 each month for 6 months, then pays 20 for each month for the next 6 months, and so on. So basically what you can think of this as is that it pays $60 for the first 6 months, then it goes up by 60 for the second 6 months, and then it goes up by 60 for the next 6 months, and so on up the line.
Why 60?
$10 for each.
Sorry.
That's why the 60. Yeah. So that's why it's an increase. That's why they refer to it as increasing empthly. We've taken this total amount of 60 and we've divided it into 6 pieces, and then we're going to increase by 60. But again, we're divided into 6 pieces, and so on up the line. Okay. So the total payment per 6-month period is increasing by $60. This payment, of course, is split into 6 equal pieces. Now, I really don't. Somebody asked me what the real life example, Kelly asked a minute ago, what the real life example was for the continuous one, which I can answer. Because in real life, in today's banking systems, things are done at the instant that the transaction is made. I have absolutely no idea how this comes up in real life. The best example that I can come up with for this is say there was another example that I was working through last night that apparently I didn't make a copy of. But say you have a bonus at work and it's a yearly bonus, but the work doesn't pay you at the end of the year, it spreads it out over the year. And then maybe next year you get the same amount of bonus, so you get both of them the next year. And then it's spread out rather than all at once. And there's reasons why that might happen. If you're looking at the tax law, for example, which if you want a good thing to go to sleep with, read the tax law. But if you look at the tax law, if somebody gives you a bonus and they put it all on one check, you're going to get dinged really hard with the income tax. So you might want it spread out over multiple pay periods rather than all on one. So that's probably the best example I could give of this kind of increasing monthly idea. Yeah.
Is this out of our book?
Yeah.
Okay.
Yeah.
I didn't catch you said that or not.
Oh, no, I didn't, but yeah, it is. Both these problems are, well, that's why I got that 8.15 and 8.17. Yeah.
That's what I thought. I just wanted to know in case I needed to go back when I was.
Yeah. Not that you're going to study?
No, I'm going to study.
Yeah. All right, so here's the idea. Here's one way that you can think of this. The increase, what do we want, present value again? The increasing monthly annuity formula is the following. It looks exactly like the increasing formula that we had before, except that the denominator changes again. So just like what we mentioned for the continuous annuity, the interest rate on top is effective interest rate for the total period. The denominator now is nominal interest rate for the total period. Compound, it'd be the nominal interest rate compounded monthly, if you will, but this, so little I is effective interest rate for the period. This is nominal interest rate for the period. And it's compounded monthly. That's how they write it. That makes sense? Okay. So for this, the hard part about this problem, at least for me, as I was working through this last night, the hard part about this problem is getting your interest rates right. I did this problem probably 3 times where I got the right answer to get using the wrong dang interest rate. Okay? So the period over which we increase the payments is a 6-month period. Right? It's not a yearly anymore. Right? So this I that we're finding here needs to be a 6-month effective rate. Okay? This needs to be a 6-month nominal rate. Turns out that's actually easier to figure out. Because, think about it, it says the nominal annual interest rate is 6% compounded monthly. Well, its nominal annual rate is 6%, right? We want nominal rate per 6-month period. Well, that's easy to find. Because if it's a nominal rate for the whole year is 6%, what's the nominal rate going to be for half of the year? 3%. Yeah, that one's not bad to find. Okay? So the IM, where did I put my pen? Ah, thanks. I hide it. So your IM here is 3%.
Why is it 3%?
The interest rate that we're quoted in the problem here is 6%, right?
It's compounding monthly.
Right, but it says nominal annual rate is 6%. Right? We want a nominal semi-annual rate because we're doing this for every 6 months. So we just need to cut the nominal in half. We're gonna do something else with the compounded monthly to get the effective rate, but for the nominal rate, we literally just need to cut it into pieces. That's what the nominal rate means, which is nice in this case.
Then what does the compounding monthly mean?
That's gonna come into a play for the effective rate. Okay. You seem skeptical. Okay, that's fine. Okay, so I need to figure out what the semi-annual rate is, this I. This is where the compounded monthly comes in. Because I know a monthly rate, right? What is the monthly rate?
Would be 0.5%.
0.5% because it's 6% divided by 12, right? Okay, so your monthly rate would be 0.5%. So how would I figure out what the 6-month rate is? This has to be a 6-month rate again.
1.005 to 6.
Good. So I do 1 plus I12 over 12, right? Would you agree? Raise it to the 6th power because there's 6. This is where your compounded monthly is coming in. There's 6 months in a 6-month period. Big surprise there. And then I need to subtract 1 off the end, right? Yeah? So what do we get? 1.005 to the 6th, and then minus 1. And then I'm going to multiply it by 100 just so I can see it. 3.0378.
Why is it to the 6?
Because we're essentially given a monthly rate, right? How in the heck did that connect to my phone? My phone's in my office.
It's ready to go.
It was ready to go.
It's the NSA, clearly.
Yeah, it's weird. Julie did it.
I don't even know if
We're given a monthly rate, right? The monthly rate is 0.5%. And I've got to compound that for 6 months to get a 6-month rate. A 6-month effective rate.
Okay. Where's his minus 1?
Remember, you do the 1 plus I m over m to the m equal 1 plus I? Remember that formula? Remember that formula? Minus 1 is coming from moving it to the other side. Right? You believe me? Okay. You look skeptical. Are you still skeptical?
It's not like a wording.
Okay, that's okay. It's in my pocket this time.
It doesn't.
What's that?
She said the wording doesn't like me either.
But I was laughing at that. It's in my box.
It's in my pocket this time. All right. So far, so good? And now it's just a matter of plugging these things into the calculator. And multiplying it by what? What's going to go out in front of this thing? By the way. It's the 60. It's the period, total period payments. That's why it's weird. I know.
I'm gonna do it wrong.
Not 10.
Not 10, it's 60, because it's the total amount of payment per period. And the period here is the 6-month period.
Can we go back up on the problem?
Wait, what?
I just want to
Everybody hates it.
You just lost me, Dr.
Everybody hates it. I know. This is why we're going to do it a second way, which I like better. What we just popped up is the handwriting tool, so I can put it in
I'm
text.
regretting it.
What's that? Regretting what?
No.
Do you have regrets, Marshall?
Yeah, I always have regrets. Every day I wake up.
Live life is no
You know?
Or the tattoo that you've seen with no recurrence.
Get that tattoo in my eyelids.
Oh,
I'm just gonna flip them. I'm gonna flip them and look at you during class.
Put your eyelid inside out like this?
Dude, don't do it.
Can you get it to stay?
Ew.
She really doesn't want to see it. I'm not
Yeah,
going to do
close
it.
your
I
eyes.
can't get it to happen.
Can't get it to happen?
Yeah.
Close your eyes, Haley.
A little odd.
Oh, that's wild.
My mom taught me how to do that. All right. So you said I lost you, yes? What was the losing part?
It increases by 60.
Okay, so it says it pays 10 at the end of each month for 6 months. So what goes out in front here is your total, not just each particular payment.
I just ripped through it again.
Yep.
And I understand where it
So that's where the 60 comes from.
Yep.
It's not increasing by 10 when it increases. It increases by 60 when it increases, right? The total increases by 60. I hate it too.
Is there a less confusing way?
Yeah, I hate
There's
it.
never an easier way.
I personally think there's a less confusing way. Yes. And I'm going to do that in a minute.
That's good.
Okay. Why is it scary to you?
Because your less confusing way is usually a lot more confusing.
Because your less confusing way usually involves a lot of algebra. Which confuses me.
Well, it will involve a little bit of algebra, but it follows another tactic that we're going to do in chapter 10. It does a similar type of thing, which is why I think that's why personally I think it's less confusing.
It's like every time I walk out of my SI class for 09A, I feel really good about my algebra skills.
Mhm.
And then I turn around and come to this class
Let's-
every Wednesday and don't feel good about my algebra.
And you don't feel good about your algebra skills?
It's like a completely different algebra. Like, half of them I feel like Dr. Joe's doing some fancy kind of algebra.
It's like I'm on top of the world and then it all comes crashing down.
How many years?
Like,
Or how many 6-month periods, I mean? 10, thank you.
And then there should be Dr. Joe should teach a college algebra class. Like Dr. Joe algebra.
Dr. Joe College Algebra? That's what abstract algebra is.
But now it's going to be Dr. Olson.
Yeah, Dr. Allison does teaching it, yes.
Who's teaching advanced calc next year?
I don't know if we're going to offer advanced calc.
Think about SI
Next year?
for
I don't know. I don't know if we'll have enough people to run it. I would take abstract and call it good.
Oh, well, you only have to take one or the other.
I'm gonna take
That's
abstract.
the only reason I planned to not graduate early was for advanced calc.
Well, if you can talk some other people into taking it, then you'll be
Grace,
fine.
take
I'm
advanced
taking
calc.
it.
There's 2 of us. They're independent study.
I'll take it.
Done.
Okay.
You already took it.
I'll do SI. I'll SI for advanced calc.
Nick will take it.
I'll understand about as much as everybody else.
We're gonna volunteer him. Advanced
I'll make Michael take it.
Why didn't you take it last semester?
doesn't have time.
I think I'm going to take abstract next fall, Dr. Joe.
Okay.
I'm just going to go pure math now.
Okay.
That's easier.
Okay.
Okay.
What are you
What else
right
do you
now?
take that would be harder?
A lot. I'd have to catch up on all the actuary classes.
There's only like what, 2?
You don't have to take like the finance.
What do I get to take?
Just recommend.
There's less electives if I go pure math, though. I kind of go.
I don't have to take any electives. As an actuary, do you?
Oh, I'm
All you
done.
I don't
have
have-
is time series and stats.
The time series.
Time series is so easy.
And I had never even seen stats before.
All right. Anybody have the number worked out?
I got 27, 17, 16.
27, 17, 16? Is that an answer? That's close, yeah. That's the E.
Does it matter if my calculator is in end mode or begin mode?
Yeah, well, it needs to be in begin mode for this one.
Oh, right. Right. That's what. Okay.
That's why it matters for this one. But I purposely wrote it out this way so you see the 2 different interest rates that are going on. This one's a little bit, I think this one's a little bit stranger because I put everything at a 6-month rate, right? Both the nominal and the effective rates had to be 6-month rates.
Who's got one? I'm just
Tasty. Didn't do it. Wasn't me, I promise. Oh. don't chew gum.
I don't understand how childish people are.
I chew fudging out, but I throw it all in the wrappers.
Yeah, I don't understand. I think it's gross.
No, I really don't get it.
Chew gum?
No, stick it under the speed hole. I'm just disgusted by you, Sydney, for chewing gum.
Wait.
I can't chew gum until I'll forget that I'm chewing gum and I'll just swallow it in like a minute.
And it's stuck in me for 7 years.
It's stupid. It's just sitting there chewing.
What was the answer?
27, 17, 16, and Dr. Joe is trusted.
Did you have a question? Oh. What'd you get?
15,000 something?
Well, it's not 15,000 something because the answers are in the 2000s. Should I go through it on the calculator?
You don't trust me, Dr. Joe?
No, I was asking Sydney if she wanted me to go through it on the calculator. I didn't say I didn't trust you. You want to go through it on the calculator? You're welcome to come
No, I
up.
definitely don't. Because I use this, and then I use this, and then I go back. I don't do the whole like fancy like inverse or.
It'll be faster when you learn how to do it.
like 10 freaking minutes before you do the thing.
Oh, you think you can do it faster than me on the one calculator? You want to go?
No, I don't. If I understood it and it was just typing it in, I think I could beat you. But
The problem is how everyone else wants to watch.
understanding wise, no, I would never get there.
Oh, maybe I didn't.
I'm just looking to confirm Grace's answer.
Oh.
Oh, I got 13,000, so. And it was a negative
I got
13,000.
negative 80,000, but I forgot to take it to the negative.
I did take it that negative.
I got 2721, but that's because I rounded the I by mistake.
So
I can get it, Dr. Joe, I
I
promise.
did 3.04% instead of 3.3%.
Okay, no.
So it was within $4, is that what you said? 27.21 instead of 27.17?
Yeah, but I rounded
But you rounded yours to .038? Is that what you said?
the point,
I got 3,000.
3.04.
You're getting closer.
Oh, I see.
Every time, you just get a little bit closer.
Oh, I forgot a number, didn't I? I forgot. I've got a wrong decimal. I got this.
Positive.
This is wrong, what I wrote down.
What do you get after the
Are we at 8.5104?
No. That's not what I got.
Alright.
There it is.
Calculator doesn't work. This is a do. So
I got
You are right.
8.7723.
Yeah, I wrote the wrong number down. I didn't put it.
723.
That's what I-
Alright, then maybe I'm.
Yes, it would be more, yeah.
It's 10, the interest rate is 3.78.
It's 3.0378. I wrote the wrong thing. I wrote the wrong thing.
What?
I know, I'm a horrible human.
I should have just looked at it.
You should have just looked at my notes instead of trusting Dr. Joe. You didn't learn yet.
Hold on. Maybe not.
Hi, how are you?
What'd you get?
Dr. Joe, I'm gonna fail the CS return.
Grace, what'd you get?
27,
CS? No,
17,
you're not.
16.
I got 27, 17, 36.
That's okay. That's what the, yeah, the
It's
things
fine.
are, yeah, the rounding errors, wherever it is.
It was around.
As
here.
long as the answers
I
aren't
did-
sense of
you have to round
sense of
to
rounding
switch
errors,
accounts.
fine.
Yeah.
I get lots of
You don't have to worry, the numbers are usually far apart that you'll know
If it's not, then you're screwed.
I don't know. Usually my rule of thumb when studying for exam is if I didn't get the exact answer, I got it wrong.
Yeah, you got it wrong? All right.
There's no guessing.
You want to see another way to look at this problem?
Yes.
Are you gonna confuse me?
Am I going to confuse you?
Yeah.
Want to try?
You want to confuse me?
I do.
Not that hard.
2717?
Yeah. Yeah.
It's the Dr. Joe error.
I got 32,000 that time. I don't know what's going on. I give up.
Are you ready?
All right.
We got better
Oops.
earlier last night.
It was only 5 years, wasn't it?
1 o'clock is early. 2 o'clock is
Right?
early.
Yeah, 5 years. Okay.
The early morning hours don't count as going to bed early, Grace.
All right. What if the problem were set up this way?
And you could just do it like this.
be an increasing annuity immediate.
Going to do a regular annual.
10
Oops, I guess I forgot to write that little thingy up there. That's all right. With 10, right?
bar your interest or bracket.
Yeah, whatever your interest is.
Yeah.
And then what we go out in front here? A 10, right? Okay. Nothing fancy, right? It was just that, yes?
Yeah.
Okay. But I would still have to have that semi-annual rate, correct? Because that would be your rate per period. So this would be 10 times your annuity due 10 periods of 0.030378. Write it down that time. 10 times 1.030378 to the negative 10 over, in this case, 0.030378.
I like this way better.
You like this one better so far? I'm not done.
Whoa. Okay.
Why am I not done?
Can you just break that?
I'm not done yet. I'm not done at all. I'm not done at all. This is just part of it.
Just kidding. I retract my statement. Let's see if it's
Yeah, I think
the
that
same
was the
here.
scary part.
It's not scary.
I really thought this got that much easier.
What's that?
I thought this got really easy on this one.
No, it didn't. It's just, but whatever this number is, I'm just going to call it X. Okay? Doesn't matter what the name of it is. We agree? Okay. Where does this put X? It puts it right here, right? We agree? What if I did the previous one, the one that's at the previous period, and put it right in next to this? Oops, there should be a 30. This same computation would move this back one period, right? But we would be at time, what? What time would we be at? Instead of being at time 0. If I move this one back using this formula, where would we be at? It's not where. Well, what time is this one at? It's the month previous.
5 months.
5/12. There we go. So where would this put it back at then here? Negative a 12th, right? We agree? Okay. So there would be an X sitting over here at negative a 12th. We agree? But what I need to do?
Move it forward again.
Move it forward one period, or one part of a period, right? A sixth of a period. Our period here is 6 months long. This is a sixth of the period, correct? So we would need to take this X, so the present value will be this X plus push it forward a sixth of a period. Right? Because we moved it, when we moved it, that IA bracket 10, when we took that one that was at time 5/12, it didn't move it to 0, it moved it to negative a 12th, right? I got to push it forward that month. Our interest rate here is a 6-month interest rate, so I need to move it forward a sixth of a period, right? What about the payment that's the previous one before? How far would I need to push X forward now? 2 periods, right? Right? I'm just saying it was a different way to think about it.
You've already lost me.
How did I lose you?
Why are we sending all these X's back and forth?
Are they the same X?
Yes, they're the exact same X. It's the same number.
Why are we pushing the one forward 2 parts?
Because this payment is at 4/12, so it's going to go all the way back to negative 2/12.
Oh, because the 10 at the half is being pushed all the way back to 0.
Right.
Okay.
Yep.
Okay.
Yep.
I'm
So this would be 3/6, and you've got 4 more payments, right? I'm not necessarily saying that, well, actually the computations will be that bad here in a minute. But I'm not saying this is more computationally easy. Whatever that sounds like really weird grammar. I'm not saying the computations are easier in this case. So it looks like I've got more of them, right? But I think to me the concept makes more sense. I'm taking an increasing annuity. Actually, I've got 6 increasing annuities. They're just at different times, right? But they're identical. I've got 6 identical, 6 identical increasing annuities, right? They're just at different times. So all I'm doing with the pushing forward thing is making them all match at the same time. From the concept, I think, to me, that makes more sense than the mismatching of the interest rates. As a concept, I'm not saying the computation's easier. What's that?
I think I like the interest rates better.
Okay, well then do the interest rate one. But what I was mentioning though is that this particular thing will pop up later on in another concept we're going to do in chapter 10. I'm going to write it this way. What kind of a series do I have? Oh, I have a geometric series, don't I? So if we add this up, what's your common ratio in that geometric series? I just wrote it as an R so you see it as the geometric. What is the common ratio? R to the 1 over 6, right? So when you add that up, you would get 1 minus, this would be R to the 6 over 6 over 1 minus R to the 1/6. Which makes the computations a little bit easier, because what is R actually in this case? It's not X, it's 1 plus I, right? Right? So I get, if I write it this way, I would get I over R to the 1/6 minus 1. Or 1 plus I to 1/6 minus 1. So you get this extra factor here.
Yeah.
It's a little bit. I don't know. We get the same answer. Do it either way. I don't care. I was just giving you a different way to think about it. In particular, at least some of the ones, actually, there just aren't that many of these examples in the review manuals. There just aren't that many problems. So the chances that you're going to see more than one on the exam is pretty small. But a lot of the other ones that I have seen don't have 6 payments, they have like 2. Well, if you're going to do 2 payments, why wouldn't you just do them for 1 and then move the other one forward and add the other? Instead of worrying about changing interest rates all around. Is my opinion. I mean, maybe this wasn't the best example because it had 6 payments in it, but that's the idea, is that if you can spread it up into 2 or, honestly, if you have annuities and it's only a couple of payments, 2 or 3 payments, it's probably just as fast to deal with the individual payments and just do them rather than typing in a big long thing with a formula. It's probably faster to do it the other way. Then you don't have to worry about setting up a formula, making sure you're in begin or end mode or any of those things, right? You just type it in. So, anyway. All right, we'll do chapter 9 on Wednesday. Very exciting.
We're reviewing probability, right?
That was the plan, unless
Oh,
you don't want
thank
to.
God. Joe, I'm so lost.
Why are you writing off the CS midterm, Grace?
What?
If you don't want to take probability, Haley, I can probably take over.
There you go.